Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Nurul Ashikin binti Tengku Mat. My matric number H19A0997. I'm from Group 16 and my member group is Nur Izni Jahara, Nur Hazira, Aisyah Nabilah and Izzatul Husna. Today, I would like to presentation of business statistic. The title is Data of Labour Force by age 35 to 39 years old in Kelantan from 1982 to 2019. Okay, what is statistic? Statistic is the studies of how to collect, organize, analyze, and interpret numerical information from data. A frequency distribution is defined as a tabulation that contains one or more variable in a sample. In the task, we collect data of labor force at age 35 to 39 years old from 1982 to 2019. In this slide, we will show the calculation of data arrangement, graphical method, measure of certain tendency, measure of variation, and measure of position.
Assalamualaikum and hi to Dr. Nazatul Asya binti Muhammad Razi as my lecturer and my fellow friends. I would like to present in our part in business statistics, which is 2.1 data arrangement. In data arrangement, we have three parts. First part is frequency distribution, second part is relative frequency, and third part is cumulative frequency. According to table 1, the frequency distribution in table showed the data number to labor force in the age 35 until 39 from 1982 until 2019 in Kelantan. It has 5 steps in frequency distribution. For the first step, we need to define sample. As data given, our group had given data from age 35 until 39 from 1892 until 2019. The data show that 36 samples have been collected. A first step to determine the number of classes K is the 2 to the rule such that 2K to the n. There was 36 samples, so it is 36. If we try K equal to 5, which means we would use 5 classes, then 2 power of 5 equals to 32. Somewhat is less than 36. Hence, 5 is not enough classes. So, if we let K 6, 2 power of 6 equal to 64, which is greater than 36. So, the recommended number of classes is 6. Step 2. Determine the class interval of width. So, the formula is class width equals to maximum entry minus minimum entry divided by number of classes. 86.1 minus 36.2 divided by 6 equals to 7.49. So we round off and we get 8. Step 3. Set the individual class limits. The individual data entry is a convenience lower limit for the first class. To find the lower limit of the remaining 6 classes, add the class weights of 8 to the lower limit of each previous class. The upper limit of the first class is 36.2, which is 1 less than the lower limit of the second class. The upper limit of the other class, and so on. For example, 36.2 plus 8 equals to 44.2. 44.2 plus 8 equal to 52.2. Step 4. Step 4. Make a tally mark of each data entry in appropriate class. Step 5. The number of the tally marks for a class is the frequency for the class. The formula for relative frequency is relative frequency equals to class frequency divided by sample class. We need to do 3 columns, which is class frequency and relative frequency. So first class is 36.2 until 44.1. We get the frequency, which is 7. Then how we can get relative frequency? Relative frequency we can get by frequency divided by sample, which is 7 divided by 36. We get 0.19. So after we add all them, we get the relative frequency as 1. Last one, the cumulative frequency distribution. The cumulative frequency of the last class equal to sample size n. We need to do 4 tables, which is class frequency, relative frequency, and cumulative frequency. So I give the step for the sample 1, which is 36.2 until 44.1. The frequency is 7. The relative frequency equals to 0.19. So how we get the cumulative frequency? We need to copy, because the frequency is same with cumulative frequency. So if frequency 7, cumulative frequency also 7. So we add on 7 is 7. And next also at 44.2 until 52.1 is also 7. So 7 plus 7 is 14. Next, 14 plus by 11 for 52.2 until 60.1. So we get 25. 25 add by 5 is 30. 30 plus 4 is 34. 34 plus 2, 36. So we get the same sample as the frequency. So that's all from my part. Thank you.
I will present graphical method. 1. Frequency polygon table and graph. A frequency polygon is a line graph that emphasizes the continuous change in the frequencies. Below show the table and graph that represent frequency polygon. Has 6 classes from 36.2 to 44.1 until 76.2 to 84.1. To get midpoint, 36.2 plus 44.1 divided 2. Then get 14.15. For get frequency X, 14.15 multiply 7, then get 281.5. And as well as under it, so based on the table, we get the graph polygon as like that. Bar chart and graph. A graph made of bar with highest that represent the frequencies of respective category is called a bar chart. In general, a bar chart can be used to depict any of the level of measurement. An important feature of the bar chart is that the bar chart are usually separate with some amount of space. To obtain lower boundaries, 36.2 minus 0.5 will get 35.7. To get the upper boundaries, 44.1 plus 0.5 will get 44.6 and also below it. So based on the table, we get graph bar chart like that.
Next, measure of central tendency. Measure of central tendency is a single value that represents a set of data. We will consider 3 measures of central tendency, that is mean, median, and mode. So, as we can see, the formula of the mean that has been highlighted in this slide. So, the solution to get the mean is 2005.40 divide 36 equal 55.71. So, the mean of the number of labor force is 55.71, similar with 55,710 of labor force. Next, median. This is the formula that has been highlighted in this slide. So, the solution to get median is 51.7 plus bracket 36 divide 2 minus 14 divide 11 close bracket multiply 8.9 equal 54.94. Therefore, the median of the number of labor force is 54.94, similar with 54,940 of labor force. After that, the mode. The calculation of the mode based on the formula is 51.7 plus bracket 11 minus 7 divide 11 minus 7 plus 11 minus 5 close bracket multiply 8.9. So because it has a bracket, so we must to calculate bracket first. Okay, continue this calculation. 51.7 plus bracket 4 divide 4 plus 6 close bracket multiply 8.9, so equal 55.26. The highest number of labor force is 55.26, similar with 55,260 of labor force.
Okay, measure of variance. Measure of central tendency is some parameter attempt to describe the amount of variation between random variable. To calculate the amount of variance, we will use three types of parameters such as rank, variance, and standard deviation. For rank, the rank of a data is the difference between the maximum and minimum data entry in the set. The formula to measure rank is maximum data entry minus minimum data entry. For solution, 84.1 minus 36.2 equal 47.9. Therefore, the rank is about 47.9. Okay, for variance, the formula to measure variance is that highlighted to slide. Okay, after we do a solution, we get variance 135.10. And lastly, for standard deviation, the formula to measure standard deviation is that highlight to slide. After we do a solution, we get 11.62. Therefore, the sample variance is about 135.10 and the sample standard deviation is about 11.62 thousand of people. Okay, that's all from me and thank you.
Hi, Assalamualaikum. My name is Izzatul Husna binti Aman. My metric number is H19A0954. Today I want to present about 2.5 measure of position. A measure of position is a method by which the position that a particular data value has within a given data set can be identified. As with other types of measure, There is more than one approach to defining such as measure. To determine the measurement of position, the data must be sorted from lowest to the highest. The different measures of position are quartiles, that is, divide the data set into 4 equal parts. Second is deciles. Divide the data set into 10 equal parts. The last one is percentiles. That is, divide the data set into 100 equal parts. Next, quartile has a tree and they are denoted by Q1, Q2, and Q3. For the calculation of Q1, I use the formula Q1 equal L is lower boundary plus n divided by 4 minus f, frequency for the class, and divided by f, multiplied by c, class width. For the first step, that is n divided by 4 equal 36 divided by 4 equal 9. L is lower boundary by class interval is 44.2 minus 0.5 equal 43.7. F is frequency for the class before is 7. C class width is 8.9 and then for FQ1 is 7. For the calculation is 43.7 plus 9 minus C divided by 7 multiplied by 8.9 and get the answer is 46.24. And next, for calculation Q3, using the same formula as Q1 and just need to change Q1 to Q3 only. First step is 3n divided by 4 equals 27. L is lower boundary by class interval is 60.2 minus 0.5 equal 59.7, and for the F, frequency for the class before is 25. Next, C for the class width is 8.9 and last is FQ3 is 5. For the calculation for Q3 is 59.7 plus 21 minus 25 divided by 5 multiplied by 8.9 and I get the answer is 63.26. And for the last is interquartile range is Q3 minus Q1. That is 63.26 minus 46.24 and the answer is 17.02. That's it for the measure of position from me. Thank you. Now I will continue presentation about 3.0, that is conclusion for the data of labor by age 35 until 39 in Kelantan from 1982 until 2019. Our group used some methods to complete the calculation the data of the number of labor force that given 000 of people, such as data arrangement, graphical method, measure of central tendency, measure of variation, and also measure of position. This method is to calculate labor statistics data. As a first step to arrange the data given, we use frequency distribution to calculate the number of classes. 6 class interval or width is 7.48 or 8 and the class limits. Next, our group also used the relative frequency distribution and the cumulative frequency distribution to organize data. For the graphical method, we use two types of such graphics: frequency polygon and bar chart. Then, we use the central tendency measure to calculate the mean, median, and the mode, in which is 55.26 or 55,260 people. For variation measure, we use range 47.9 or 47,900 of labor force. The quartile method is used to calculate the range between quartile 1.02 for measurement position. After that, the shape of the distribution divided into two types, such as symmetric and non-symmetric. The symmetry, a vertical line, can be drawn through the middle, a graph of the distribution, and the resulting halves are approximately mirror image. It have uniform and bell shape, or known as normal shape. While the non-symmetric, a distribution in which there is no such mirror imaging. It have skewed to the left and skewed to the right. Based on our data, the shape of the distribution is normal shape. This is because we get mean bigger than median, smaller than mode. Following the formula, mean is bigger than median and smaller than mode. The graph which has been shown is bell shape, or known as normal shape. It is because graph 55.71 bigger than 54.94 and smaller than 55.26. That's just the conclusion from me about data of labor force in Kelantan. Thank you.